Hey everyone, welcome to Statssy. In today's session, we will going to learn something from R programming. R programming, it's a very important programming language particularly for data analysis and statistical programming. So I'll be covering something interesting. So let's move to the screen. So today we will going to learn about paired t-test in R programming. Now you see that hypothesis testing is a very important, it's like close to my heart, it's my favorite topic, and today I'll be covering something from that part, that is paired t-test in R programming. I'll explain you step by step, so stay with me. Okay, so let us say you got a scenario, you are hired as an analyst, okay, and you are told to use some R programming skills and perform some analysis. So let's talk about what the analysis is. So you are given with a scenario. The scenario is that chill pill is a new drug which claims to reduce the blood pressure. So like when someone is in stress, so we say that okay, take a chill pill. So just like that, we say chill pill is a drug which some company released, and that is like a blood pressure reduction. That's what the aim of this drug is. Okay, and it is tested. See, it's not in the market right now, but okay, they have developed this, so they have to test that drug, that okay, is it working or is it not working. So they tested it on 50 patients to understand if the drug works as intended or not. Okay, and you are working as an analyst at this company. Okay, for the chill pill, you are working as an analyst for the chill pills clinical trial, and you need to recommend based on your statistical analysis or data analysis, whatever you call it, okay, to the company that whether this drug is actually effective or not, because company don't know whether this drug is yet effective or not. It has to be analyzed through clinical trial, so then only they will be able to know. So what exactly we want to do? So obviously chill pill's fate is in your hand. Now you are the one who will decide whether this drug will going to be launched in the market or not. Okay, so this is the scenario. So now if I talk about blood pressures, I'll give you just some basic things. First thing is, if you see, blood pressure is generally measured in two numbers. Okay, like if you see blood pressure, it is written as 120, 80, 140, 60, and like this. Commonly it is being used. Okay, so now what does it indicate? It indicates the pressure your arteries when your heart beat. Okay, so when your heart beat, okay, just like this. Okay, like this. Okay, so when this heart pumps the blood, there are two phases. One is contraction and another is it expands. Okay, the expansion. So the first number that you see in a blood pressure is basically the pressure which arteries when your heart contracts. Okay, the pressure on the arteries when your heart contract. So if you see here, the second diagram, this shows how particularly the heart functions. Okay, so this is called as systolic blood pressure. Second number that you see, it is basically the pressure when your heart goes at rest. Okay, rest means it expands. Okay, so basically contraction and expansion are the two processes, and when it contracts, we talk about the systolic blood pressure, and when it expands, we talk about the diastolic blood pressure. Okay, so that's why 120 is what we call a systolic blood pressure, and 80 is basically your diastolic blood pressure. Now, what analysis exactly we have to perform? So what exactly the analysis we have to do? See, we will evaluate the change in both the systolic and diastolic blood pressure. So this is what you have to perform as an analyst, as a data analyst. And how will you perform it? For each patient, the blood pressure is measured before and after taking the chill pill. So there were 50 patients. They were they might be stressed, so their blood pressure was recorded, and after that they were given with the chill pill, and the blood pressure is recorded again. That's what is being done. Now, to determine the change in blood pressure, we will be using paired t-test to understand that how the systolic blood pressure changed and how the diastolic blood pressure changed separately. Like we are performing this analysis separately for both the blood pressure. Now, in actual clinical trial, things are very different. So don't consider it to be the actual trial. This is just an example that I have taken to explain you how it is being used and what is the practical utility of it. So now you'll think that, okay, why I am considering paired t-test? So paired t-test is a very important concept. Why? Because what we are measuring before and after comparison. Like we are comparing what was their blood pressure before and after taking the chill pill. So in before and after comparison, when the patients are same, the best technique to analyze the change is paired t-test. Okay. So basically what we do is, it is ideal for comparing measurements taken from the same group. This is very important because the same 50 people, you measured their blood pressure before and you measured it later. So that's why the paired t-test is very important. Second thing is, it accounts for individual variability. Like 50 patients you have, 50 patients, each person is different. Their eating habits, their sleeping habits, their body type, their health, everything is different. They are coming from different background. Obviously 50 people cannot be same in any manner, even if they are from the same country, or even if they are from the same ethnicity, whatever you say, they are obviously different. So individual variability exists in the 50 patients, and different patients may react differently to different drugs. That's a very common thing that happen. Okay, so because we are basically interested in finding that what is the overall change that happened in those 50 patients, so individual variability is something that we have to take into account, and that's why paired t-test becomes the first and the best choice. Okay, matched pairs, this is what t-test is meant for. Matched pairs because each patient serves as their own control. Like generally what happens is, when we perform some clinical trial, there is a control group, there is a treatment group. Okay, but here what we can see, that same patients are being tested before and after. So obviously this can act as the same patients can act as a control group, and the same patients are being acting as a treatment group. If you want to learn about what control group and treatment group, I'll make a video separately on that. Okay, then measurement scale, very important. That blood pressure is a continuous variable. Obviously when we measure the blood pressure, you say it's 120, 140. It's not exactly 120 or it's not exactly 140. Like heart do not beat or do not push the pressure in discrete manner. It's obviously a continuous variable that has to be continuously. Like it can be 120 point something, or it is 125 point something. Okay, like 125.63, that can be a blood pressure. Okay, so obviously when we have a continuous data with us, we have to use measurement scale as continuous. We have to use the t-test because it considers the continuous variables. Okay, then distribution of differences. Now very interesting, whenever you apply paired t-test, what happens is, you have a data of 50 people, you are comparing it with the same person, okay, before and after. So if you take the difference, so that difference is what matters to us. So that difference is what will going to give us the idea that is the blood pressure being changed, is the blood pressure changing correctly or incorrectly. Okay, then specific hypothesis testing that we are doing. Okay, it allows for testing specific hypothesis which is related to mean difference. Like the blood pressure, we have separate people, so their difference is what is going to matter to us. Okay, so that blood pressure which you are going to measure based on the difference, that like systolic blood pressure you will be measuring separately and diabolic you will be measuring separately. So these separate measurements will give you a bit of you can say control over the variability that can happen in this experiment. Okay, now what do we do in the t-test? So this is what the most important thing. Being an analyst, you should know about what exactly going to happen in the t-test. So I'll explain you that. The first thing what you do is, you prepare the hypothesis that, okay, what is the hypothesis? So as you know, we want chill pill to obviously succeed in this, but still we say that no difference in the in means between the paired groups happened. Okay, let's say I want to check whether the chill pill is actually a good drug or not. What I'm doing is, I'm testing the hypothesis that my claim is that the particular medicine is helpful. It actually reduces the blood pressure. But what is the alternate to it? What if my claim is not correct? So the opposite of my claim is that it is not effective. Not effective means there is no change in the blood pressure. They have same blood pressure before, they have same blood pressure after taking the chill pill. Okay, so we write the alternate and null hypothesis, very important. Then what we do, we calculate the difference between each pair of two related groups. Now, what two related groups? So I'll show you some data. So see, I have a data set like this where I have patient ID in the first column. Okay, this column shows the different patient ID, like patient ID 1, 2, 3, 4 up to it ranges till 50. Okay, for these 50 people, I have first is the systolic blood pressure SBP underscore before. Okay, so this means that this is the blood pressure that is being recorded before they have taken the chill pill. Okay, the systolic blood pressure. Then SBP after records the blood pressure after taking the chill pill. DBP means the diabolic blood pressure, which is recorded before taking the chill pill. Obviously not recorded separately in one you can say one measurement. We recorded both, so we arranged the data in this manner. Similarly, DBP is diabolic blood pressure after you have taken the chill pill. Okay, so this is what your data is. Now what I am interested in measuring, I am interested in measuring the difference between these two. Okay, the difference between systolic blood pressure and before and systolic blood pressure after. And similarly, I am interested in measuring the diabolic blood pressure before and after. Okay, so now for measuring these two, what I am interested in, I am basically calculating the difference between the matched pair. So now why matched pair? If you see here, for example, patient number 2. So for patient number 2, I will be measuring the difference in patient number 2. It's not like I will be subtracting before blood pressure of patient number 2 with after blood pressure of patient number 3. Obviously that will be wrong. You have to understand in the matched pair that same patient is being tested twice. Okay, so we'll be measuring that. Okay, now moving further, what is the third step? Third step is the difference that I get for each patient. I'll be calculating the mean and standard deviation for that. Okay, because mean and standard deviation, like summary statistics will give you the idea that how that difference is and what is the variations that are happening. We'll understand that also. Okay, then we'll calculate the t-test or t-statistic. So t-statistic is a quantity which is being calculated after, you can say, normalizing the data. Okay, or not exactly normalizing, but it's similar to that part, but you can just understand it in this way, that we'll be calculating t-statistic after calculating the difference in the blood pressure for all the patients. Okay, the next step we'll be finding the degree of freedom. So you know why pair t-test have a degree of freedom based on which we calculate the critical value. Okay, if you are not aware of how the hypothesis testing works, you can watch other videos on my channel. I have prepared the video on how does the hypothesis testing work in almost all the fields like business, finance, or healthcare, anywhere. Okay, then we will calculate the p-value. P-value means the value which helps you to figure out that whether the results are statistically significant or insignificant. Okay, and then finally you will make the decision based on those p-value, whatever you get from that. Okay, and finally based on that you will decide the fate of chill pill, whether this company will going to make money on selling chill pill, or whether this drug will be discarded. So that's what you have to do as an analyst. Okay, so now, and then we will finally write the recommendation that, okay, this is my recommendation, how exactly the chill pill perform or how the patients are feeling after and before taking the drug. So let's perform this analysis in reality and see how it works. So for that I'll be opening my R Studio. You can also open your R Studio like this. Okay, in this R Studio we have 4 different windows. Right now you can see 3 windows because I haven't created the 4th window yet. So what I have to do is, on this R Studio, first I'll go to this file and click on R script. I will be thrown on this window. You can see untitled 1 it is written. So what I will do is I will just click on save and I will give it some name. So it opened on my different screen, so you can just think about it. You can open, like when you click on save, give you a window to save this file. So I call it as R code, let's say, very simple R code. Okay, so in this R code, this is my R code, rcode.r file. So r.r is the extension. So now in this file, what I will be doing is I will be performing this particular analysis. So how do I perform this? So the first step is obviously to import the data. Which is the data? This is the data. This is the blood pressure data, blood pressure.csv. This contains this particular data, okay, which I have created for you. So now what I have to do, first thing is I have to read this data. Now to read the data, I will write the command read data. This is just a comment that I have given. So now let's say I call my data set as blood pressure underscore data. Okay, blood pressure underscore data, any name, whatever you like. And this is the assignment operator in R. You will just write this assignment operator, smaller than sign and a hyphen. And then you will write the command read.csv. Put a bracket here, and inside this you will name the file or put the path of the file. So I have this, if you see here, I have this blood pressure data and rcode.r, both files in the same folder. So I'll just write that file here. So to write that file, I'll write here blood underscore pressure.csv. Okay, so now you will see that as soon as I run this command, so to run this command I will select it and click on run. When I click on run, you will see that the blood pressure data is imported in my environment, and you can see BP underscore data. It has 50 observations and 5 variables, which means 50 records and 5 features, 5 columns. Okay, that's how we talk about, like as a data scientist, how you talk about the data. You don't say columns and rows, you say features and observations. Okay, features and records, these are the common terminology. So if I click on this data, you can see I have got the name of different like columns here. I can see patient ID, some random character is appearing, but we can ignore that, that's totally fine. We'll understand how to clean the data in later videos. Then there's blood pressure and all those. So all my data is imported correctly. Okay, so now after I have got the data, what I'll do, generally what I do is the first thing I do is I check the structure of the data. I check the information about the data. So for checking the information, I'll write the command here. I will write the command str. So str is a very common command which you use to check whether your data is correct or not, or correctly imported or not, R has understood the variables correctly or not. So I'll just write this BP underscore data, the name of my data frame. Okay, like this. And if I run this command, you can see in the console window I have this data imported correctly. Like here, str command gives you the data as data frame. It has 50 observations, 5 variables, patient ID column, which is an integer, obviously 1 2 3 4. This is the blood pressure, systolic blood pressure before. It is showing as an integer because what we have done here in the data set is that we imported the data as like we have created the data in a way that everything is non-fractional, like whole numbers, integer values here. So obviously R understand this as an integer and it gives you this values like SBP. Similarly, SBP after, DBP before and DBP after. So all these are correctly imported, that you can see. Now after I am confirmed that okay, my data has been imported, should I directly perform the test? Obviously no. What we have to do is always and always in the data analysis we perform a bit of summary statistics, like descriptive statistics, to understand, to grab the information about data. Because just looking at this data in your Excel file, obviously it's not very clear to you that how or what is the distribution, what is the average blood pressure of these people. Is there some person who is suffering from high blood pressure or low blood pressure? So that is what you have to understand from the data. So to perform a bit of analysis, what you can do is you can check minimum value, you can check maximum value, whatever you like to perform, you can perform on that. For example, I'll just show you how the minimum value you can calculate. So for calculating the minimum value of, let's say, systolic blood pressure before for the patients. So for all the patient, I want to know what is the minimum blood pressure that this data set has, because maybe someone is suffering from low blood pressure problem, so we should obviously take care of that person. So we will write our data set name. So to find out the minimum value in this particular column of SBP before, what you will do is you will write the name of the data set, and after writing the name of the data set, you will put a $sign. So as soon as you put the $sign, R will automatically recommend you that okay, you have these columns in this data frame, so you can select that. So I'll select SBP before, and I will just select this command and run it. So you can see as soon as I run it, it gives me the value as 113. Like okay, no problem, the person is fine, but 113 might be a bit of you can say a low blood pressure. Okay, but fine, we can't do anything. This is the job of the person who is selecting people who are being considered for the experiment, for the clinical trial. But as a data analyst, we don't focus on that. As an analyst, you don't need to worry about that. So okay, so that's the minimum. Similarly, you can calculate the maximum. You can type BP underscore data dollar after, or let's say same before. For the before person, I'll just run this command. I'll select it. Okay, so 134, that's kind of fine, you can say, not significantly high blood pressure, but yeah, 134 is good one blood pressure. Okay, so now after we have found out some of the summary statistics, you can find out average and a lot of things. So I'm just writing here summary statistics, and I'm not going too much into that depth, because our purpose of this video is to understand paired t-test. Okay, so now before performing the paired t-test, what we will do is we will see that is there actually some differences that are happening. Like if without performing the test, can we see that okay, the blood pressure before and after, are they similar or are they different, just to get an idea that okay, things are similar or not. Okay, because generally inferential statistics comes later and descriptive statistics come before. You will always try to find out what is the present situation in the data, rather than jumping to making inferences. That's what the common practice is. Okay, so to do that, what I will do is I will create a box plot, and in the box plot, what I want is I want to show the systolic blood pressure distribution before and after. These two things I want to show. So what I'll do is I will write here BP underscore, what's the name? Okay, BP underscore data. R gave me suggestion, so I'll just type it directly and select this SBP before, comma, I will type the second, that is BP underscore data, and SB, this is after. Okay, and I will just run it. I'll just run this command. So as soon as you run this command, you can see that on the bottom right window, you will see the plot here. If you click on zoom, it will open up. Okay, it opened on my another screen. So here you can see that the blood pressure 1 and 2, now obviously 1 and 2 is like a placeholder, because 1 means the before and 2 means the after. If you want to improve this plot, I'll give you suggestion that how you can improvise this plot. So for that, what you can do is you can type a command called as names. Okay, names, it's a standard argument in the box plot, where you can mention that what exactly name you want to provide. So for example, I have two blood pressure, so I'll provide them name as before and sorry, it has to be as strings. So before and after, like this. Okay, so it's just like some basic name, whatever you like, you can give them. So here I ran the command. Okay, so now we have the plot again, and here it is, the plot. So you can see the systolic blood pressure before the people have taken the chill pill, it was this. There was some, if you see this dot, it is like this dot is showing the outlier person, but let's ignore that outlier. For now, we will just focus on that. Okay, overall plot of before is appearing a bit upside. If you see here carefully, it is being upside, and the overall plot for the after is on the lower side. This dark line, the dark middle line, horizontal line, it shows the median blood pressure. So the median blood pressure before taking the chill pill was this, and median blood pressure after taking the chill pill is this. So obviously we can see a difference is appearing. So descriptive statistics, that's why it's important that it is showing you that yeah, there is a difference, but is this difference statistically significant? Like do we consider this to be something which can help or which can approve chill pill from the FDA? Like, is it something that of that kind? That is what the point is. So you have to understand that to actually test that if the difference exists or not, first you have to go for the descriptive statistics. So this descriptive statistics gave you the idea that yes, there is a difference exists. But imagine if these two lines are closer to each other, or they are like parallel, like median value for before and median value for after are appearing parallel. So this gives you an idea that yeah, might be that test will not going to play any role, like test will not going to help me, because ultimately there is no difference that I can see within the descriptive statistics. So similarly, after creating this type of box plot for systolic blood pressure, you can do one for diabolic blood pressure also. So I will just I'll just copy the box plot, and here instead of systolic blood pressure I will take diabolic blood pressure, and moving forward here I'll just take diabolic blood pressure after. So if I just run this command, you will see again the diabolic blood pressure here. You can see here the difference. Again, I can see that blood pressure before was higher and blood pressure after is lower for the diabolic one. So I can see that yeah, difference exists. But imagine again if they would have been closed, like these two dark vertical bars which are representing median value, they are close to each other. So I would have said that okay, no need to apply the test because they will not going to be different. Okay, so descriptive statistics gave you the idea that whether they are actually different or not different. Okay, so we visualized the difference, that okay, there is actually a difference exist. Now what is the next step? Now we will going to perform the inferential statistics. So basically we will be performing that. Okay, for this we will understand that how to apply the matched pair t test. Okay, so I'll write the command here. You can just copy and paste this command. You can just directly run it. So what I'll do is the command in R. So see, one thing I would say like R is my personal favorite. I just love to play around with R. I just love to code in the R because it's very self-intuitive language. You have the commands, you have the keywords, the functions are very self-intuitive. For example, here if you see, I want to create the box plot. So you can see that I've just typed the box plot and it just appeared. Okay, so that doesn't happen mostly in other programming languages. So no offense to Python, but yeah, I love R more than Python. Like Python is great language. I build machine learning models in Python, but R is my personal favorite. Okay, and I hope our community is listening and they will make R more user friendly and for the web development, so that I can create softwares in R. Okay, so coming to the point, we will understand how to conduct the t-test, match pair t-test. So for that the command is very intuitive. You just need to write t.test. Okay, so the command is t.test. Now in this t.test, what I have to do is I have to give the value, or I have to give the data that I want to test. Okay, so now if I go back to my data frame, you can see what I need to do is I need to test whether the systolic blood pressure changed after taking the chill pill or not. So for doing that, in the t-test, what I have to supply? I have to supply the two columns. One is for SBP before and SBP after. Okay, so what I'll do is I'll write here BP underscore data and then $sign. So SBP before, comma BP underscore data $sign and SBP after. Okay, now this is not just the command that will give you the test. Okay, because t-test has multiple possibilities. Like this command t.test is applied for one sample test, independent sample, equal variance, non-equal variance. Everything is done by this command. So you have to give some additional information to perform the matched pair test. Okay, so to perform the matched pair test, what you have to do is you have to give a command which is called as paired. So paired, it appears. So if you put this paired as true, R will understand that yes, these two data columns are basically matched pairs. Okay, they are not independent pairs. Like, it's not like we are testing 50 people before taking the drug, okay, and 50 some other people after giving them the drug. It cannot happen. This is not how the test can be done, okay. We have to check the effect, that how the drug is playing on the particular people. So what I have done is, I have just mentioned the command, I have just mentioned my columns, okay, and I am told R that paired t-test is true, so I want the test to be paired t-test. So what I'll do is, I will just run this command. So if you run this command, it will print out a lot of value. So I'll just shift this here. So you can see, as soon as I run the command, I have paired t-test and it is showing me all the details. So this is your data, then it's showing the t statistic, test statistic. It is showing me the degree of freedom, and it is showing me the p value, which is 2.2 e to the power minus 16, which means very small value, okay, very small value here. So what this test I did is, I did this test for the systolic blood pressure. So I'll mention here that test for systolic blood pressure, okay. Now similar test I have to perform for the diabolic blood pressure. So I'm being a bit of conscious here. So this is, I'll just change it to diabolic blood pressure. So here I will write is diabolic blood pressure before, and here I'll write is what happened, and here I will just write diabolic blood pressure after, okay. Now if I run this command also, what I can see, it showed me the test. So I have got the test for diabolic blood pressure, and I have got the test for systolic blood pressure. Now what you can see, how to interpret these results, okay. So let's talk about first the systolic blood pressure. When you run this command, this is the command which ran. So console shows everything. So here is your result. First thing you should notice here is, it is showing us the mean of the difference. So what does mean of the difference means? R basically performed an operation. What operation? R basically took these two columns and took the difference of these two. So I'll just insert some additional column, and I'll write here difference. So what R did is, R calculated this value minus this value, and this is for the all patients, and then took the average of this particular column. This is what 5.06 is. So when you see this mean of difference, this is basically nothing but the difference in the average of the differences that they have taken for each person, okay. And what's important here is test statistics. It is 46.654, but maybe you are confused that, okay, what does this value signify, okay. So better thing is to use this p value. If you see this p value, it is coming out to be 2.2 e to the power minus 16, which is like very, very small. So what does this 2.2 e to the power minus 16 means? This means that if you repeat this experiment infinite number of times, then the chances are that 2.2 e to the power minus 16, you can say the percentage of cases will going to have a different result compared to what you are looking at the result, okay. So what does this mean? This means that 1,000,000 times if this experiment is repeated, it will result in my favor. It will show that yes, the blood pressure actually reduced, the systolic blood pressure actually reduced. So similarly, if you talk about the diabolic blood pressure, so again you can see the p value comes out to be very small, which means that diabolic blood pressure is also actually reduced. So if both type of blood pressure are reducing, does that mean chill pill is a good drug or not? Is the fate is still in your hand? So what I can say, that because the p values are very, very small at any significance level, I will say that because the p values are very, very small, I can reject the null hypothesis. And what was my null hypothesis? If I go back to this, you can see that my null hypothesis was that there isn't any difference, there is no difference. So I will reject this. So what does this mean? This means that there is a difference that actually exists, and that difference appears to be a positive value, because you can see the difference in before and after. This is the positive values, okay. So being this positive values, you can say that this is correctly done, the analysis is performed correctly. So now you can write your recommendation. So how will you write the recommendation? I'll just write here to explain you. So the first thing you will say, pair T test for systolic blood pressure showed that the P value is less than 0.05, which is 5% level of significance that we commonly use. Okay, this means that chill pill is actually reducing the systolic blood pressure, and we can reject the null hypothesis. Okay, similarly, what about the diabolic blood pressure? We have seen the p-value is still low, so I can write that since, or you can say that pair T test for diabolic blood pressure showed that the p-value is less than 0.05. This means that chill pill is actually reducing the diabolic blood pressure, and we can reject the null hypothesis. Okay, since we can reject the null hypothesis in both cases. So what do you say, chill pill is a good drug or not? Obviously it's a good drug because it is able to reduce both the blood pressure. So we can say that chill pill is a good drug, and it can be sold to consumers. Now obviously this is like a too much optimistic recommendation that I am giving, but as a data analyst you just need to mention that, okay, do you approve or do you not approve? The rest of the things are taken care of by the other team people or product people, or the FDA and all those people. Okay, so that's it guys, that's it. What we have to understand, how the match pair design works, how the match pair t-test works, and how you can apply it in a scenario. So this might have given you the understanding that, okay, match pair technique, how it is applicable in a practical real world scenario. Okay, so I hope you enjoyed this. I hope you learned about blood pressure, and I hope you learned about R programming and the match pair t-test. And if you have any questions, please leave in the comment, and see you next time. Thank you.